Hi, welcome back. Today we're going to go over past state test questions from 2021 and older for ratios, rates, and percents. So let's start off with our packet. And how can you use this video, by the way? If you want to jump to a particular question, you can fast forward. If you haven't done the questions yet, you can pause it, work through the question, and then unpause it to check to see if your solution agrees with mine or your strategy and solution agree. All right, so let's start off with number one. Kate has a coin collection. She keeps 7 of the coins in a box, which is only 5% of her entire collection. What's the total number of coins in Kate's coin collection? All right, so we're going to use our percent proportion here. The percent will go over 100. We're writing our percent in fraction form. That's equal to the part over the whole. So we're told her collection is 5%, or the amount that she keeps in the box is 5%. So 5% is the same as 5 over 100. And part of her coins are kept in the box. So 7 of them are in a box. The rest, we don't know where she keeps it, but we don't know what the total is. We'll put our variable here. From here, we're going to cross multiply 100 times 7 and 5 times x. So that's going to be 700. 7 times 100 is 700 equals 5x. Since this is a multiple choice problem, you will not have a calculator. You're going to be expected to work out 700 divided by 5 to figure out what x is. So we'll just show the long division here on the side. 5 can go into 7 once. Difference is 2. I'm going to bring the 0 down to make it 20. 5 goes into 24 times exactly. And 5 can't go into 0, so I'll bring the placeholder up. So that means Kate has 140 coins in her collection. Number 2, the relationship between Robert's age R and Julia's age J can be represented by the equation shown below. So Robert's age is equal to Julia's age plus 3. So Robert is 3 years older than Julia, in other words. So let's see which one of these tables expresses their ages appropriately. All right, so that means we're going to add 3 to Julia's age each time. That's going to equal Robert's age. And I can see right away 12 plus 3 does not equal 9, so option A is not appropriate. Let's look at the second one. We're going to add 3 to Julia's age. So 3 plus 3 should give us 6, not 9. So we know option B is not appropriate. Let's go to option C. We're going to add 3 to Julia's age. Well, 6 plus 3 does equal 9, 12 plus 3 does equal 15, and 18 plus 3 does equal 21. So it is option C. All right, question number 3. A bagel shop sold 8 plain bagels and 13 rye bagels. What's the ratio of the number of rye bagels to the number of plain bagels? So I'm just going to write this down. We want the rye bagels to the plain bagels. There's 13 rye, and there are 8 plain. So the ratio is 13 to 8, option B. Number 4, Joe walks on a treadmill at a constant rate. The equation below describes the relationship between T, the time he walks in hours, and D, the distance he walks in miles. D equals 4T. Which graph represents the relationship between the amount of time Joe walks and the distance he walks? So I'm going to jot down here a little ratio table, distance and time, and let's say Joe walks 1 hour. That means he's walked 4 miles because we need to multiply the time times 4 to make the number of miles. If he walks for 2 hours, 2 times 4 would give us 8 miles. If he walks for 3 hours, 3 times 4 would give us 12 miles. Right? So now we're going to look at which of these graphs represents those points appropriately. I notice for option A here that when he's walking 1 mile, we have 1 hour, he's walked 4 miles. When he walks for 2 hours, right, as I move up, he's now walked for 8 miles. And that matches up with our ratio table. So it looks like A is the option. Let's double check that B and C are not correct. When he's walking for 4 hours here, he's only walked 1 mile, so we know B is no good. When he's walked 4 hours here, he's only walked 4 miles. No good as well. When he's walked 4 hours, he's walked 4 miles, also no good. So option A. Number 5, there are 230 calories in 4 ounces of a type of ice cream. How many calories are in 6 ounces of that same ice cream? So let's set up a proportion here. We'll put the calories in the numerator, the number of ounces in the denominator. So 230 over 4. And we want to know how many calories are going to be in 6 ounces. The 6 is going to go in the denominator here. All right, from here we can cross multiply, or you can find the unit rate. How many calories are in 1 ounce, and take those calories in 1 ounce and multiply it by 6. Both strategies are good. I'm going to cross multiply here. 230 times 6 is equal to 4 times x. So I'm going to show that multiplication on the side. I don't have my calculator here. Right, that's 1,380. And to figure out what x is, we're going to divide that by 4. So 1,380 divided by 4. 4 goes into 13 3 times. That's 12. Remainder of 1. I'm going to bring the 18 down. 4 goes into 18 4 times. That's 16. We have a difference of 2. And I'm going to bring the 0 down. 4 goes into 25 times exactly. Right, so that means x, the number of calories for the 6 ounces, is 345. Option C. All right, number 6. All the students in the 6th grade either purchased their lunch or brought their lunch home from home on Monday. 24% of the students purchased their lunch. 190 students brought their lunch from home. How many students are in the 6th grade? All right, so this is a really good percent problem. All right, so we notice 24% of the students purchased their lunch. We don't know the number of students who purchased their lunch. We don't know the total number of students. So using the 24% here doesn't help us because we don't have anything to set up our proportion with. However, if we take all the students, which is 100% of the students, and subtract the 24% from it, that's going to give us 76%. And that's the number, the percent of students who brought lunch. We can use the 76% who brought lunch because we have a number of students who brought lunch. So in our proportion, we're going to put 76 over 100. 190 is part of the students who brought their lunch. We don't know what the total number of students in 6th grade is. And now we're going to cross multiply. So 100 times 190 is 19,000. And that's equal to 76 times x. All right, we're going to divide here. Again, I don't have my calculator, so we're going to show the long division. 76 is pretty close to 80, and I know 80 times 2 is 160. 80 times 3 is 240. That would be too big for the 190 here. So I know 76 goes into 190 twice. And that's 152. When we subtract, we get a difference of 38. I'm going to bring our 0 down. Right, again, 76 is pretty close to 80. I know 80 times 5 is 400, which is really close to 380. So I'm going to try 76 times 5. And let's see what that gets us. And that's exactly 380. Right? And I know 76 can't go into this last 0 here, so I'm going to bring a 0 up. So that means there's a total of 250 students in the 6th grade. All right, number 7. Pat bounces a basketball 25 times in 30 seconds. At that rate, approximately how many times will Pat bounce the ball in 150 seconds? All right, so I'm going to set up our proportion, the number of bounces to the number of seconds. So 25 times in 30 seconds. And we want to know how many bounces in 150 seconds. We could cross multiply here. However, I see that 30 times 5 makes 150. So that means 25 times 5 would have to give us x. And 25 times 5 is 125. So Pat's going to bounce it 125 times. Number 8. A machine fills boxes at a constant rate. At the end of 35 minutes, it has filled 5 boxes. Which table represents the relationship between the number of minutes the machine fills boxes and the number of boxes it fills? Well, if it's filling at a constant rate, we can figure out the unit rate, right? So 35 minutes divided by 5 boxes means we are taking 7 minutes to fill 1 box. So I want to look for which one of these tables shows that information. The number of minutes is 7, the number of boxes is 1. Right, so minutes is 7, boxes is 1 for part A. It is not for choice B. And for C, we have them reversed, so that's not correct. And for D, it's also not correct. It's not 7 to 1. So our option is A. All right, let's go to our next question. A salesperson had $240,000 in sales last year, which is 60% of the sales she had this year. Which equation could be used to determine X, the salesperson's total amount of sales in dollars for this year? Okay. So we don't know our total. That's 60% of this year. Okay. So we've got 60 over X. Our percent is always, 60 is always over 100. Percent is always over 100. And let me move this so I can write. We'll bring it over here. Right, and so, they've had 240,000 in sales last year. That is 60% of this year. So we don't know the total amount for this year. That means our denominator here has to be X, and the 240,000 is the part. So which one of these matches here? And that would be option A. And I know the two ratios have been switched, right? But I notice the 60 is over 100, just like we have here, and the 240,000 is over X. So option A. All right, let's go to number 41. Kim rode her bicycle 135 miles in 9 weeks, riding the same distance each week. Eric rode his bicycle 102 miles in 6 weeks, riding the same distance each week. Which statement correctly compares the number of miles per week they rode? So it looks like they're comparing the number of miles each week. So we need to find the unit rate. So let's figure out how many miles Kim rode each week and how many miles Eric rode each week. To find the unit rate, we're going to have to divide. So 135 divided by 9 tells us how many miles per week. And it looks like Kim rode 15 miles per week. And let's see how many miles Eric rode per week. Goes in once, that's 6. We have a difference of 4. 6 goes into 42 7 times. So Eric rode 17 miles, Kim rode 15 miles. So option A, Eric rode 2 more miles per week than Kim. That is correct. 17 is 2 more than 15. All right, next question. Dana and Monique are dog groomers. Dana's workday is 10 hours and Monique's workday is 8 hours. Dana and Monique each work 40 hours per week. All right. On Monday, Dana groomed 15 dogs in 10 hours and Monique groomed 10 dogs in 8 hours. They each earned $12.75 for each dog groomed. Assuming that for the rest of the week, Dana and Monique groomed the same number of dogs per workday as they did on Monday, what will be the difference in their weekly salary? All right, so there is a lot to this problem. And there's several different ways it can be solved. So as you're going through this, if you're watching me work it through and your strategy is different, that's okay. as long as our final solutions are the same. All right, so I see Dana's workday is 10 hours, and she groomed 15 dogs in 10 hours. All right, but Dana's working 40 hours. Okay, so she's working 10 hours per day. That's 15 dogs. And to get to her 40-hour week, we're going to have to multiply that by 4. So that would give her the full 40 hours. And 15 times 4 means she has groomed 60 dogs. Okay, well, we have to multiply the $12.75 for each dog groomed by 60 to figure out how much money she's earning. So $12.75 times 60. First row is going to be all zeros. Then I'm going to put my placeholder in. 6 times 5 is 30, carry the 3. 6 times 7 is 42, plus 3 is 45, carry the 4 up. 6 times 2 is 12, plus 4 is 16, carry the 1 up. And 6 times 1 is 6, plus 1 is 7. Oops. There we go. All right, now we're going to add. And we have 2 decimal place values in our factor. We need 2 in our product here. So Dana has made $765 grooming dogs for a week. Now let's look at Monique's information. Monique works 8 hours per day. And it looks like Monique groomed 10 dogs in her 8 hours. Okay, so we've got to multiply that by 5. That's going to give us the 40 hours, and that means she's groomed 50 dogs. Okay, so now we got to figure out how much money is Monique making. I'm going to erase my work here. We're going to redo $12.75 times 50, and I'll show you a little bit of a shortcut at the end where you didn't have to do this multiplication twice. Placeholder, that's 25. 5 times 7 is 35, plus 2 is 37. 5 times 2 is 10, plus 3 is 13, and that would be a 6. So we've got 0, 5, 7, 3, 6. Again, 2 decimal place values in our factor. That means we need 2 in our product. So Monique has made $637.50. We want to know what's the difference between their weekly earnings. So we're going to subtract those amounts. 765 minus, and this is a part 2 question, so you'll have your calculator with you. You can use your calculator. I don't have mine with me, so I'm showing all the multiplication and the subtraction here. It's going to be a 7, a 2, and a 1. So the difference is $127.50. All right, here's a little bit of a shortcut. I noticed that Dana grooms 60 dogs, Monique grooms 50 dogs. That's a difference of 10 dogs. So Dana is grooming an extra 10 dogs. Really, we could have multiplied the $12.75 times the 10 extra dogs to find the difference. And that multiplication would take us straight to $127.50. All right, let's look at our next question. Jason has a coupon for $2.50 off any electronic book from an online bookstore. If the original price in dollars of an electronic book is P and the discounted price in dollars is D, which table shows the relationship between P and D? All right, so P is our book price, and D is our discounted price. So the discounted price needs to be $2.50 less than the book price. So we can do this part here mentally. $3 minus 50 cents is $2.50. $4 minus $4 minus $1.50 is $2.50. So I'm subtracting the book price and the discount price to tell me how much was saved or how much was discounted. That's the value of the coupon. You could have done $3 minus $2.50 gives you 50 cents, or $4 minus $2.50 gives $1.50, right? So it looks like it's going to be option A. Let's confirm that it's not option B. No, we're not going to add $2.50 to the price to give the discounted price. That wouldn't make sense. We're not saving any money there. The discounted price again for D here is greater than the original price. When you discount, you're removing money, it's cheaper. And if we look at option C here, the difference here is only 50 cents, not $2.50. We haven't subtracted $2.50 from it. So it's not choice C. It is choice A. All right, next one. Last year, Chessa made 32 one-cup servings of soup for a school party. This year, she'll make 2 times the amount of soup that she made last year. How many gallons of soup will Chessa make this year? Well, last year she made 32 cups. This year she's going to make 2 times that amount. So let's double it to figure out how much she's making this year. So this year she's making 64 cups. All right, if you remember in the land of gallon, there are 4 queens. Each queen has 2 princes. And each prince has 2 crowns. This is really tiny here, but it's just so I can count the number of C's, cups, in the gallon. All right, I'm going to skip count here. 2, 4, 6, 8, 10, 12, 14, 16. So there are 16 cups in 1 gallon. All right, so we're going to divide 64 by 16, and that's going to tell us the number of gallons. 64 divided by 16 is equal to 4, so that means she's making 4 gallons of soup this year. All right, next question. The area of an airplane's wings is related to the airplane's lifting force, which holds the airplane in the air. The table below lists several wing areas of the corresponding lifting forces. The ratio of lifting force to area is equivalent for all pairs in the table. What are the values of X and Y? Okay, so this ratio is equivalent all the way through. So that means we're multiplying 125 by the same number to make 1,785, or we're dividing 2,250 by that same number to make 150. So let's see, what are we multiplying by? I'm going to do the division. 1,875 divided by 125. It's going to tell us what to multiply or divide by. 125 goes into 187 once. And we've got a difference of 62 when I bring this 5 down. To make it 625, 125 times 5, I believe, is 625. Let's double check. Yes. So that means we're multiplying by 15, or in the opposite direction, we're dividing by 15. All right, so to figure out what X is, we're going to have to divide by 15. And I'm just going to erase my work so I have some space here. And we'll do 5,625 divided by 15. All right, 15 goes into 56 3 times. That's 45. We have a difference of 11. I'm going to bring the 2 down. 15 goes into 112 7 times. That's 105. We have a difference of 7. I'm going to bring the 5 down. 15 goes into 75 5 times. So that means X is 375. So in my options here, I can cross out B and D. And to figure out what Y is, we're going to multiply 420 by 15. All right, 420 times 15. 5 times 0 is 0. 5 times 2 is 10. Carry the 1. 5 times 4 is 20. Plus 1 is 21. We need a placeholder, and then I have a row of 420. So that means Y is 6,300, and that is option C. Next question. Feyen's dog eats 8 ounces of dog food each day. Feyen bought a 28-pound bag of dog food. How many 8-ounce servings are in a 28-pound bag of dog food? Okay, so there are 16 ounces in 1 pound. All right, and we want to know how many servings there are. If each serving is 8 ounces, that means there's going to be 2 servings in 1 pound, right? Because 8 ounces plus 8 ounces is 16 ounces, but we have a 28-pound bag, so we're going to multiply. I'm squishing it in here, sorry. 2 times 28 to give us the number of servings, and that's 56 servings. Residents of a small city voted on whether to allow a developer to build a shopping center. The number of votes in favor of the shopping center is 4,400. The number of votes against the shopping center was 17,600. What percent of the voters were in favor of the building to the shopping center? So in our proportion, we want in favor compared to the total. We don't know the percent, that's what we're looking for, so it's going to go over 100. We know in favor was 4,400, and to figure out our total, we're going to have to add the in favor, 4,400, with 17,600. And that's 22,000. Okay, so now we can cross multiply. 100 times 4,400 is, I'm going to add 4 zeros here, 440,000. And that's the same as 22,000 times x. When we divide, I'm going to show a little trick if you don't know it. These cross reduce. Right? The zeros, each set of zeros can be canceled out. So I can match up 3 zeros in the top with 3 zeros in the bottom. Those cancel out. 44 divided by 22 is 2, and this last 0 comes down here. So x is equal to 20. So 20% were in favor of the shopping center. All right, let's go to number 47 here. The table below lists 4 masses and their corresponding approximate weights on Earth. The ratio of weight to mass is constant. Which statement describes the ratio of weight to mass and the value of x in the table? So it's saying, what's the ratio of weight to mass? Weight to mass. And I see all of these are in fraction form, so I'm going to put weight over mass. Okay. Well, weight over mass, we're going to put 196 as the weight over 20 as the mass. And it looks like they've simplified it to 10 for the mass. So we're going to divide both of these numbers by 2. So that gives us 98 over 10. So that means I can cross out options C and D. Those have the wrong ratio, they're in the wrong order. So 98 over 10. And now we have to figure out what x is. Okay, so let's set up a proportion. If we know it's 98 over 10, oops, for the weight over the mass, we know what the weight is. It's 1,078. We don't know what the mass is. Okay, so we're going to have to cross multiply here to figure out what x is. 10 times 1,078 is 10,780, right? It's 1,078 times 1, and then we're putting a 0 on, and that's equal to 98x. We're going to divide by our third number here, divide by 98. All right, so I'm going to make some space here so I can show the division quick. There we go. Okay, so 98 can go into 107 once. Our difference is 9. I'm going to bring the 8 down. 98 goes into 98 once, and then that's 98. And it can't go into 0, so it's 110. So option B here. Okay, let's go on to number 19. Derek earned 94% out of 100 on a science test. When he received his test back, he saw a minus 17 at the top of his test. The inequality below shows the relationship between the number of points Derek thought he lost to the number of points he actually lost. Negative 17 is less than negative 6. Derek's teacher offered several extra credit options on the test, but did not report how many extra credit points were gained at the top of each test. Which statement compares Derek's score to the number of points lost? Okay, so he thinks he lost 17 points. Minus 17 relates to the points lost. So he actually lost 6 points. So we want to know what's the difference between these two. Right? That's going to account for his extra credit. So we can take the absolute value of them to figure out what's the difference between them. 17 minus 6 is a difference of 11. So that means he gained 11 points, right, in extra credit. So let's see which one of our multiple choice options matches this. Derek scored a 71% but received 23 extra credit points for an overall score of 94. Nope, not true. Minus 17 would take him to 83. Okay, Derek scored 77% but received 17 extra points for an overall score of 94. No, I disagree. There's no mention of any 77. If he lost 17 points, again, he scored 83, not 77. Derek scored 88, but received 6 extra credit points for an overall average of 94. That's not true either. It's this one here. He scored 83, because 100 minus 17 is 83, but we added 11 points back for an overall score of 94. All right. The table shows the amount in gallons of blue paint and yellow paint that are mixed to form a shade of green. How many gallons of blue paint should be mixed with 25 gallons of yellow paint to form the same shade of green? So we want to fill out our ratio table here. So there's several ways to do this. I'm going to find the simplest form ratio here. If I divide both of these by 2, that means we're mixing 3 gallons of blue paint with 5 gallons of yellow paint. I know 5 times 5 is 25, so 3 times 5 gives us 15. So he's got to mix 15 gallons of blue paint to make that shade of green with the 25 of yellow. Okay, number 23. The cost of 625 bolts is $100. What is the cost of 10 bolts? Okay, I would either suggest finding the unit rate or setting up your proportion for this. If you're setting up a proportion, you want to put the bolts over the cost, right? 625 over 100 equals 10. Number of bolts is 10, and X is the cost. All right, that's one strategy. If we want to find the unit rate instead, we're going to divide. Remember, the money, the dollars, is always divided by the quantity. So I'm going to do 100 divided by 625. So we're going to need to add some decimal places to do this division. 625 going into 100, it can't. I'm going to put a placeholder up and bring my decimal point. 625 goes into 1,000 once. When we subtract, we have a difference of 375. And I'm going to bring my 0 down. All right, 625 goes into 375. I'm going to guess about 6 times because 600 times 6 is 360. So let's double check. 625 times 6, it's 30, 15, and it goes in exactly, right? So So that means the unit cost is 16 cents per bolt. Since we're buying 10 bolts, we're going to multiply that 16 cents times 10. And that's going to give us $1.60. Or if you cross-multiplied, you also would have cross-multiplied and found that x is equal to $1.60. All right, 2 more questions here. Jaden made a pot of chili with 48 ounces of ground beef and 2 tablespoons of chili powder. He made another pot of chili with the same amount of ground beef, but he used 3 times as much chili powder. How many pounds of ground beef per tablespoon of chili powder did he use in the second pot? Okay, so in the first pot, he used 48 ounces to 2 tablespoons. And this is beef to chili. Okay, in the second pot, he used the same amount of ground beef, 48 ounces, but he used 3 times the amount of chili powder. So now he's using 6 tablespoons of chili powder. We want to know how many pounds of ground beef per tablespoon. Well, if there's 16 ounces in 1 pound, I can divide 48 by 16 to figure out how many pounds there is. 48 divided by 16 is 3 pounds. So this is going to become 3 pounds. And this is still the 6 tablespoons. Now we want to divide and figure out how much per tablespoon. That means the tablespoons needs to equal 1. So I'm going to divide the tablespoons by 6. We also need to divide the pounds by 6 as well. 3 divided by 6 would look like this for long division. I'm going to add a decimal point and a 0. 6 goes into 3 0 times. Bring your decimal point up. 6 goes into 30 5 times. Exactly. Right, so that means our ratio is 0.5 or 1/2 pound per tablespoon. All right, last question. A factory adds 3 drops of red and 2 drops of blue to food coloring to make white paint, and that paint is going to be each pint of purple paint. Okay, so that's 1 pint of purple. The factory is making 50 gallons of purple paint, so we want to know how many drops of each food coloring is needed for 50 gallons. All right, I'm going to go back to our large G. Land of gallon, there are 4 queens. Each queen has 2 princes, or a prince and a princess, or 2 princesses. Okay, so let's figure out how many pints are in a gallon here. 2, 4, 6, 8. So if we multiply this by 8 and the number of drops by 8, that's going to be the amount of drops in 1 gallon. All right, so this would be 24 of red and 16 blue. Now, we're not making 1 gallon, we are making 50 gallons. So now we have to multiply that by 50. That's going to tell us how much of each we need. Let me move this. Okay, so to make 50 gallons, well, let's do 24 times 50 first. Placeholder, that's 20, and that's 12. So we need 1,200 drops of red, and 16 times 50. And again, you should have your calculator. This is a part 2 question. So you'd be typing this into your calculator. And it looks like we need 800 drops of the blue. All right, there's our final solution. If you have questions on any of these, please ask in class or through Google Classroom or email. Thanks for watching. Have a good day.